All right, moving on to part 2. So number 9, anything raised to the power of 0 equals 1. So if you had 15 to the 0 power, that equals 1. Now you have to be careful though, because this x to the 0 power is only on the x. So technically only the x to the 0 cancels out, since that equals 1. And then this is saying -4 times 1 times y to the 5th. So when you simplify it, you are still going to have -4y to the 5th. And then this last one, all of these powers are raised to the 0 power. So remember, even this whole number has an imaginary 1. So if I were to multiply, this would be 1 times 0, 9 times 0, and 6 times 0, which means that everything inside is 0, so all of this will equal 1. All right, number 10, if an exponent is negative in the numerator, move it to the denominator to make it positive. So, just like I taught it in class, if they're not happy upstairs, you will then move them downstairs to where now they become happy. Same thing with B. If they're not happy upstairs, you will move them downstairs to where now they are happy. And then C, you have to be careful because 17 is to the positive first power, so 17 is happy where he's at, and y to the second power is happy where he's at. So you are going to keep 17 and y squared up top because they're happy where they're at. But then since x to the -4 was not happy, you will move him downstairs to where now he is happy. All right, 11, if an exponent is negative in the denominator, you will move it to the numerator to make it positive. So if they're not happy downstairs, you move them upstairs to where now they're happy. Be careful with this one. So first off, you always want to simplify if you can. So notice how there's an x squared and an x to the first down here at the bottom. So if we were to simplify the x squared and x to the first power, remember you just subtract. So 2 minus 1 is 1. So now we have 5x over y to the -3. And since your y to the -3 is not happy downstairs, you'll move them upstairs with everybody else. So this will now be 5xy to the third power. And that's your answer. And then C, again, you always want to simplify first before moving exponents up and down. So you can simplify your 3 and the 6 here because 3 divided by 6 is just 1/2. Your x over x to the third power, this is technically x to the first. So you can say x to the first minus x to the third. So 1 minus 3 is -2. So this will be x to the -2nd. And then do the same things with your y. So y to the second subtracted by y to the -4th. 2 minus a -4 is a +6. So you have 1 times x to the -2nd, y to the 6th over 2. And then notice that this x squared is not happy. So you will just move them downstairs with a 2. So you will now be left with 1y to the 6th over 2x squared. And you don't have to leave this one here if you don't want to, but either way, you'll still get the same answer. Okay. All right, number 12, when you have an expression in parentheses, you multiply. So this is a power to a power. You multiply the exponent outside the parentheses with every term inside the parentheses. So a lot of students missed a question like this on the quiz because they forgot that there is an imaginary exponent on that whole number 3. So when you're multiplying this 4 times all of your exponents, you want to make sure you multiply it with that exponent on the 3 as well. So 1 times 4 is 4, so that would be 3 to the 4th. 2 times 4 is 8, so that would be x to the 8th. And then 3 times 4 is 12, so that would be y to the 12th. For B, you want to simplify everything on the inside first before you start multiplying times everything. So notice how I have coefficients that I can multiply. So 2 times 3 will give me 6. x to the 5th times x to the 2nd, I just add my exponents, so that will be x to the 7th. And then all of that will be to the power of 2. And then this is when you can start doing the power to the power rule. So again, whole numbers have an imaginary exponent, so when you're multiplying this 2 times everything on the inside, you should be taking 2 times the 1, so that would be 6 to the 2nd power, or 36. And then 2 to the 7th power, which is 14, so that would be x to the 14th power. Alright, and then same thing with C, you can simplify inside of your parentheses first. So when you take 14 divided by 7, since these are coefficients, this will leave you with 2. And then a to the 4th divided by a to the 1st. Remember, you just subtract your exponents, so 4 minus 1 is 3. So it'll be a to the 3rd. And all of this will be to the power of 3. So that now, when you're taking your power to the power, remember that there's an imaginary 1 on your coefficient of 2. So you can multiply this 3 times everything on the inside. So this will be 2 to the 3rd power. And then 3 times 3 is 9, so a to the 9th power. And that is your answer. Or if you just go ahead and solve that, 2 to the 3rd is just 8. So it will be 8a to the 9th. Alright, 13. So this is scientific notation. So the mass of the sun is 1.989 times 10 to the 30 kilograms. The mass of the earth is 5.98 times 10 to the 24 kilograms. How many times bigger is the sun than the earth? So the first thing you guys need to think of is, what operation are we going to be doing? Well, we are going to be dividing if we're trying to figure out how many times bigger is the sun compared to the earth. So we want to take 1.989 times 10 to the 30th and divide it from 5.98 times 10 to the 24th. Alright, so I'm going to pull out my calculator here. So remember, with dividing scientific notation, this is a lot easier than adding and subtracting, because you don't have to have same base to the same power. So you're just going to divide your constants like normal here. So if you take 1.98 divided by 5.98, you should get 0.3326. And then the rule with exponents is, when you're dividing, you can just subtract your exponents. So 30 minus 26 is 6. And a lot of students are going to stop here, but you have to remember, this number, your first number in the scientific notation, has to be a number between 1 and 10. So if it's not, you're going to have to move your decimal point. So to make this number a number between 1 and 10, I can move my decimal point 1 unit to the right, so that now it's 3.326. But when I do that, I have to change my exponent. And I just need to figure out, since I moved it 1 unit to the right, is if it's going to go up 1 or down 1. So say to yourself, did I just make this number bigger or smaller? Well, if it was 0.3326 and I made it 3.326, I just made this number bigger. So I need to account for that by making this exponent smaller by 1 to make my two scientific notations be equal to one another. So if I move the exponent one time to make it bigger, I need to subtract 1 from this exponent to make it smaller. So the sun is 3.326 times 10 to the 5th times bigger than the earth. All right, number 14, the population of Maryville is 5.6 times 10 to the 3rd. The population of Asheville is 1.3 times 10 to the 4th. How many more people are in Asheville? So this is asking for the amount of people. Notice how it's not asking for just like the scientific notation form of it. So you could do the scientific notation and then change it into its standard form, or we can just go ahead and change the scientific notation's standard form So if this is 5.6 times 10 to the third, that means that I need to make this number bigger. So my exponent is telling me how many times to move my decimal point. And since I'm making 5.6 bigger, I should move it to the right 3 times. So when I do that, 1, 2, 3, I'm adding 2 extra zeros, so this will be 5,600. And then I can do the same thing over here, so 1.3 times 10 to the fourth. My exponent is telling me how many times to move my decimal point. And since I'm making 1.3 bigger by multiplying it times 10 4 times, I need to move my decimal point to the right 4 times. So I'm going to add in 3 extra zeros. And since it's asking how many more people are in Asheville, I'm going to take my 13,000 minus the 5,600. So when I do that, 13,000 minus 5,600 will give me 7,400 more people. Alrighty. So again, you guys can stop the video at any time, but I'm just going to go ahead and keep on going. Alright, number 15. So if a new TV show had 3.2 times 10 to the 8th viewers for the first episode and 2.7 times 10 to the 9th viewers for the second episode, how many total viewers watched the first 2 episodes? So we are going to be adding our scientific notations. So let's go ahead and do that. So we need to take 3.2 times 10 to the 8th plus 2.7 times 10 to the 9th. So remember, when you're adding and subtracting with scientific notation, you need to have same base to the same power. And in this case, we do not, because we have 10 to the 8th and 10 to the 9th. So I want you to change your smaller exponent to the bigger one. So I need to change this 10 to the 8th to 10 to the 9th. And when I do that, I'm going to have to change my decimal over here. So notice how I added 1 to my exponent to get 9, which means I am making this number bigger. So I need to account for that by making this decimal smaller so that this scientific notation down here will equal the same scientific notation up here. So to make my 3.2 smaller, I can move it to the left 1 time since I added 1 to my exponent to now make this 0.32. Okay? And then now notice how I have same base to the same power. So I can add like normal. So add your constants, 0.32 plus 2.7. Let's double check here. So 2.7 plus 0.32, that gives me 3.02. And then you keep your same base to the same power. And always double check to make sure that this is a number between 1 and 10, and if it is, then you did it correctly. So there's 3.02 times 10 to the 9th viewers altogether. Alright, and the last one here, so there are approximately 3.1 times 10 to the 8th people in the United States. If on average each person has 4.1 times 10 to the first coins lying around their house, how many total coins do all the people in the United States have? So hopefully you guys know that we will just be multiplying here. So when it says what operation will you use, you will multiply. And then multiplying with scientific notation is easy because you don't have to have same base to the same power. So what you're going to do is you're going to multiply your constants like normal. So if you were to take 3.1 times 4.1, you get 12.71. And then adding your exponents, because when you multiply exponents, you just add them. So 8 plus 1 is 9, so 10 to the 9th. And then notice that this number is not between 1 and 10, so you're going to have to move your decimal point to the left 1 time And when you do that, you're making your number smaller, so you need to account for that by making this exponent bigger by 1. So then this will be 10 to the 10th, and this will be coins.